Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello, and welcome to this week's episode of the DooDoo Diva Smells Like Money podcast. Today, we are visiting with Lewis Titus, the Vice President of Titus Wastewater Solutions. And so welcome to the show, Lewis.
Well, thank you, Suzanne. Been a long time since we've talked, but me and you go back a long ways. We're old friends.
Yes, we are. And I've been waiting to bring Lewis on the podcast because he was in the process of developing a really unique technology and an approach for aeration for ponds and lagoons. And so it was not quite ready for primetime viewing, about a year ago when we started, but now it is. And so I am really excited. I love introducing new technology on the show and new ways for approaching wastewater, especially when it's innovative and disruptive, as you will see. For those of you who are just listening in, if you are interested, you might later on want to come back and view this on the YouTube channel, because Lewis is going to be sharing some video to show how this technology works. But I am going to ask you, Lewis, to just kind of, for those who are just listening, to kind of maybe give us a visual explanation of what is happening on the screen, for auditory purposes. But with that said, just kind of want to get a little history on you and aeration and what you've been doing, and really what brought about you wanting to develop this product and this unique approach. Aeration is not a new approach for lagoons, but why coming about it this way, the limitations that you saw for aeration technology, and really kind of what prompted the idea of, maybe we need to build a better mousetrap.
Yes. Well, I've been in aeration business for a number of years. I've worked for some other companies in the past. Our company's a little bit unique. We're a rep company, and we repped a lot of products, and I had a lot of ideas of my own. And we decided to go off on our own and start manufacturing. And we started out with some aeration units for sewage pump stations to get rid of fats, oils, and greases, and for odor control. And that product's been very successful. We specialize in using ozone for that. And it's a very simple process using airlift technology. And we've refined it to a whole new level that we feel is way above everybody else. And I have competitors in the business, obviously. And when I got started on this new project, I was in Washington, in Puyallup, Washington, at a trade show, and I was working with a senior engineer for an energy consulting company that basically helped municipalities and industry cut costs in any way they could. And when you start looking at aeration, usually if you go to any municipality, to wastewater treatment plant, unless you have a facultative lagoon, the number one cost for these facilities is aeration, because it takes a lot of power to run the aerators.
Right.
And I was talking to this engineer, and he's looking at my pump station unit, and he said, "Well, what do you got for lagoons?" And I said, "Well, I don't have anything for lagoons, but I got one in my head. I've been thinking about this for a couple of years, and I've been wanting to build one." Well, it just corresponded with COVID hitting. I was in Washington, and this is the week that COVID hit the Kirkland rest home, that had a lot of fatalities from COVID. And it turned out that was the last show for like 2 or 3 years in the state of Washington, and really nationwide. It pretty well shut down trade shows. And it also shut down my traveling because I travel a lot. I like in-person. I like to sell in person. Yeah, and I'm kind of the chief salesman for my company, although we have a lot of rep companies working for us now that are taking the banner from me and doing that. So long story short, I was kind of stuck at home in my shop, and we had a big shop and we had quite a bit of equipment. And I said, you know, I'm going to build one of these things. I got it in my head, and we started out with a very small prototype. We made it out of sheet metal and expanding foam, and it was very crude, but it actually worked. And so we went to about a 40% scale model, again, just made out of sheet metal and very crude. We had a 6,000 gallon tank to play it with it. And when we kind of got all the technical aspects of it lined out, we had to take the big plunge. Our units are made out of rotationally molded polyethylene. So they're very, very durable, very heavy duty, but you got to build the molds, and the molds are very large. These are big machines. And so it was a big financial investment for my company to actually manufacture some of these. And I was working with a rotational molding company out of Baker City, Oregon. And they were instrumental in the design on this thing. They really, their expertise in building molds is amazing. And long story short, we ended up coming up with 3 different models. And the basic difference in the models is for different depths of ponds. Some ponds are real shallow, some ponds are real deep. And so we made 3 different models of this, and we incorporated some new technologies that we've applied for and received some patents on now. And again, well, I have competitors. There's nothing quite like ours. And to my knowledge, and I've done extensive testing with this thing, it's the most efficient mixing aerator for lagoons. And when I say lagoons, we're also selling these for EQ basins, mixed liquor basins. I have a project in Arizona right now for mixed liquor basins. But this is the most efficient machine I've seen as far as transferring oxygen and mixing. And
What's
then the third
secret sauce, Lewis? What's the secret sauce? Like, why is it, you know, there have been things around for a long time. What makes this one so unique in comparison to other things that we may have been using in the past?
Well, if you go to wastewater treatment plants, they usually, their aeration basins are big square rectangular tanks. Right. And they have a array of 9-inch heads. And these heads today typically have a flexible membrane diffuser. And it covers the entire bottom of a tank. And so when you cover the entire bottom of a tank, when you're releasing the air bubbles from these, it's going to mix the entire tank because you have air bubbles coming up through the entire tank. You don't have that luxury in a lagoon. There are some companies that try to make bottom diffusers for lagoons, and yeah, they transfer oxygen just fine, but they're terrible mixers because they sit in one place. One of the big things that we've found in the aeration business, the biggest drawback to almost every aeration system out there for lagoons is the fact that the aerators don't move. They sit in one place. Okay. They're typically cabled in with stainless steel cables, and most of them are mechanical. They got propellers. They either throw water up in the air or they have thrust and they pull air down through a horizontal hollow tube. And as the air gets pulled down, the propeller breaks up the bubbles. Lots of problems with both those units. Number one, especially the units that have the hollow shaft is very inefficient, and have tried to improve the efficiency, and they did improve the efficiency about 40% by putting a blower on there and blowing air down that. But there's still problems with all that. And again, mainly anytime you got a propeller, they sit in one place. People just don't move them. It's too hard to disconnect cables, but you either have thrust or you have rotational torque. So we went a whole different approach. We use an airlift pump, and the way it works is we pump air down through a vertical structure. It's got a large concrete weight down at the bottom that acts like the keel on a sailboat, and it keeps the unit vertical. It's got a big float up on top, and the bottom of that float is it's shaped to where it will push the highly oxygenated water out at about 15 degrees, push it out towards the bank while it pulls up either from the bottom, or we also make side port units, and it keeps a big circular motion. But the big deal with this is two things. We're the first ones to take that membrane technology that they use in wastewater treatment plants on 9-inch little diffusers, which, keep in mind, they're running about 3 or 4 CFM out of each one of those. Very little air goes through them. We made a very large membrane diffuser, and it's first conical. It's a cone shaped, and it's a membrane, and the membrane has about 40,000 tiny slits, and they're slits, they're not holes.
Okay.
And what a slit does is it will open and release a bubble and close behind it. So one of the problems that my competitors have is they use fixed pour diffusers and they plug up all the time. If you put them in mixed liquor, for instance, you can't keep them clean. They're constantly having to pull them and clean them. Mm-hmm. You literally have to pull them and clean them. Mine doesn't plug up. You can put it in real heavy solids and it won't plug up.
Well, why is that? Is it because of the conical shape, or the way that the design itself?
Well, it's the membrane. The membrane it's a slit. It's not a hole. When you have a fixed hole, it's a fixed size. Material will get back in, debris will get back into that thing, and it'll plug, especially when you shut them down. When you shut them down, water backflows into them, and they get some nasty stuff in there. And when you start them up again, that stuff will plug up the hole. So pretty quick, you got to clean them.
Okay.
And believe me, I've cleaned a lot of those things. The membrane, again, it's a slit, and the membrane opens, releases the bubble, closes behind it. It acts like a check valve.
Okay.
That's probably the best way to put it. And even if it does get debris in it, it's a flexible membrane, so the air pressure will blow it right through. Where a fixed hole won't do that. It just plugs up. So there's no saying that
so what I'm hearing is that you saw some of the things that were, problematic in other devices, and figured, well, then I want to make sure that I don't incorporate that into my design.
Yes.
That we know that these are problematic. Let's go about it a different way.
Exactly. And we incorporated ideas that are used again in bottom diffusers.
Okay.
It's similar to what we did, only these things are enormous. They're like 30 inches in diameter, and the cone shape. And the cone shape, what it does is it keeps the bubbles from combining. So one of the problems when you're releasing a lot of air bubbles into a small area is the bubbles will tend to combine. And everybody in the aeration business knows that the finer the bubble, the better the oxygen transfer.
Okay.
You don't see a lot of coarse bubble diffusers anymore. They used to be pretty common, but they were very inefficient at transferring oxygen. And tests have actually showed that they're also not as efficient at moving water. So we're doing two things with that air bubble. We're transferring oxygen into the water, and we're moving huge amounts of water, because as the air bubble goes up through the water, the surface of that air bubble pushes water. So the bubble's actually pushing water up, and as you do that, it draws water up from the bottom. It's a Venturi effect. And so what you get with an airlift technology, you have to have a pipe inside of a pipe. So we have an air pipe with a big thrust conical cone in the bottom, releasing air, and as that air travels up through, we call it the oxygen transfer chamber. It's about a 3-foot diameter chamber. We're transferring oxygen as that goes all the way up through there, and we're pushing water. And as that water reaches the float, the big float, it gets pushed out horizontal and down at 15 degrees, and it comes out of that thing at very high velocity. These things move huge amounts of water. We can move up to 900 million gallons an hour, depending on how hard we push them. So what we've done is improve the mixing efficiency tremendously, and the oxygen transfer efficiency is, as far as I know, is as good as anything else in the market, as far as floating aerators for lagoon systems. This is basically an animation. One problem I have with these, it's very difficult to video one of these things in operation underwater. I've tried to do it even in clean water testing. I can't get a video camera to get great video of this. So we spent a lot of money and had an animation done. This is showing, this would be more of an EQ basin, but it could be a lagoon, it can be a tank, it can be pretty much anything. And what this is showing is an air source. We use a blower that's land-based. We can use one blower per aerator. We can use one blower per 3 aerators. So we do it in different configurations. And we have a flexible hose that goes out there, and we tie it off with a piece of rope. There's no stainless steel cables on this because there's no torque and there's no thrust. So we can literally let the wind move these around the basin. The center pipe you're looking at, that is the air pipe. Down at the bottom is the perforated fine bubble diffuser. And we make these with bottom intakes or with side intakes, and there's 2 different purposes for that. But we deliver that air in there. It goes down to the thrust conical perforated diffuser. It comes out, and what you're seeing, really bubbles, you can't push a bubble down into the water, but what you can do is transfer oxygen into water. And once the oxygen is dissolved into the water, you push that highly oxygenated water back down into the water. That will push down. Bubbles will simply roll up around the edge of it. As you can see, these things are just kind of moving around. It's showing the rope tied up to a couple different tie-off methods. We put cables on them. We use concrete blocks, but we recommend that they keep them moving. This is showing the different sizes. We make an FL4 for shallow ponds, a 6 for deeper ponds, and an 8 for really deep ponds. And this is showing bottom intake or side intake. Sometimes we have a combination of both.
Clip. What are we seeing here on the screen, Lewis?
What you're seeing is one of our 8-foot FL. This is an FL8, which stands for 8 foot. What that means is the diffuser is 8 feet down in the water. Now, what we found is the deeper we can push that diffuser, the more oxygen we can transfer with the same machine. And so an 8-foot machine, it takes 3 4-foot machines to get the same oxygen transfer as 2 8-foot machines, simply because you can transport more oxygen the deeper you go. Unfortunately, not all the ponds are deep enough to put an 8-foot machine in, which is why we make 3 sizes. Now, what we've also found is the efficiency, as far as oxygen transfer efficiency, it stays pretty consistent because a 4-foot machine doesn't take as much horsepower to run as an 8-foot machine. So the transfer efficiency remains about the same. Now I'm going to start this up, and this is going to show it in operation. You can see it's a 360-degree discharge, and it's coming out of there at about 15 degrees. You can see this is moving huge amounts of water. What you really can't see is most of that water being discharged is discharged down out of sight underwater, because the concrete ring at the base of this thing actually pulls that float. It semi sinks it, pulls it down about 6-7 inches. So we discharge the water subsurface, which is also part of our patents, is subsurface discharge. But the neat thing with this, with the 365-degree discharge and no moving parts, you can freely move this around the basin. I can grab a piece of rope and just drag this all over the basin. I can pull it up into the corners because it's not throwing water in the air. I got a project right now. They're using high-speed surface aerators. They throw water up in the air, which they're pretty efficient at transferring oxygen. The problem is in a tank like this, when you pull it up in the corner, it's going to throw water out on the ground. Mine won't do that. So the reason they're going to this technology is they can put these in their basins and pull them up in the corners and improve the mixing in these EQ basins to get rid of the sludge buildup in the corners. Some of the other advantages is when you're not throwing water up in the air, you don't have the odor problems.
I was just going to ask about that, that I imagine would help cut down on any odor from the spray.
And that's a safety issue as well. When you're talking human waste and you're throwing it up in the air, it vaporizes. And I can tell you from personal experience, the people working around these things don't like breathing in human waste. It's not safe in my view. We produce no vapors, so that health hazard goes away. And we think it's just a better way of doing it.
Thank you for sharing those 2 video clips that, that really helps to illustrate and understand this a bit better. So one of the other things that you had mentioned to me and we talked about before you came on the show was some of the advantages of this from a safety standpoint, in comparison to, typical things, aerators that spray, aerators that are used in cold climates, especially, when we think about spray and humor waste and hazards to the operators that are standing next to this. Maybe just kind of review with us some of the advantages of looking at a technology like this from a safety standpoint, as well as operational standpoint in relationship to different climates, especially climates that are going to have, heavy freeze thaw cycles.
Yes, well, we spent a lot of time looking at the problems that some of the existing technology has, and all of them have problems of one sort or another. So what we try to do is address all of those. But in our view, safety is number one. Safety should be number one for everybody. That should be their major concern. So number one, we didn't want to have any boat access maintenance. So this thing is actually, all the maintenance is done on the bank, on the blower system. There is no boat access maintenance. Number two, there's no 480 volt power out in the middle of a lagoon. Electricity and water don't mix very well. And when you're running 480 volt power out there and high amperage, again, that's a safety factor. Vapor is a big safety factor when you're throwing water up in the air and vaporizing it, which is pretty efficient at transferring oxygen. The problem is the odors and the vapor, and you're talking human waste. And so the operators around those systems are, if the wind's right, they're breathing that. And nobody wants to breathe that. And I can tell you, I've talked to operators that's their number one complaint. So we've eliminated all those problems. We have no moving parts. It's a plastic box. There's nothing to maintain. There's nothing to grease. There's no bearings to go out. There's no shafts to break. There's no propellers to wear out. All that is gone. It's a plastic box. All the maintenance is on the bank. And again, no power out in the water. There's an air hose that runs out there. And with a subsurface discharge, we've eliminated all the vapor. The other problem with water being thrown in the air and vaporizing is you simply can't use those kind of systems in cold weather. They will freeze. And so they have to shut them off in the winter. Well, wastewater is 365 days a year. We're in Casper, Wyoming, and we hit 30 below zero this winter. And we hit 18 below zero about 2 weeks ago again. So one of the reasons we moved our operation to Wyoming is our market for these really is cold weather states that do not have very good options for aeration right now, because of they simply won't. Most of the technology won't work in cold weather. Mm-hmm. Ours will. So that's the big safety features with it.
It's a great option. I mean, it's something that it's great. This is why I love bringing new technology people and people that have innovations, is that they see a need in the marketplace that nothing is answering. Like, okay, we've got something, but it's good, but it's not quite there yet. So how do we take it to the next level to solve those pain points? Especially what you were saying is your ideal market is those folks who don't have the access or can't use other technology just simply because of environmental factors. Exactly. But like you said, wastewater is 365 days a year. You can't say, oh, well, I'm sorry, it's cold today, you can't use that. You have to find something that will work in those kind of climates. So, for those of you listening, how can people get more information about this? Are there pilots or tests or places they can see this in action or get more information and see if it might be a viable solution for their plant? How can they learn more, Lewis?
Well, it's a new technology. We've been working on it for 3 years. We've done a number of pilot tests with it. Our first pilot was in Arlene, Montana, and those guys are really good. If somebody wants to see one in operation, it's a great place to go see it. Arlene, Montana is extremely cold. It was 30, 40 below zero this year. And they've had it running for almost 2 years now. and they had mechanical aerators before with propellers. And the problem they had is they ragged up all the time. So every day they had to go out in a boat and pull the propeller up and pull the rags out of the propellers and put it back into service again, only to have it rag up again the next day. Very common with mechanical aerators. If you have lagoons with rags, propellers and rags don't mix. So we installed one of our units. We doubled their oxygen transfer efficiency. And the lagoon now is, after 2 years, they've had zero maintenance issues. The only maintenance is on the blower. It's been running 2 years nonstop, never ragged up, never plugged up. Their dissolved oxygen levels are running at 7 milligrams per liter, and that's with the machine actually turned down. And in the winter, when it hit 40 below zero this year, the 30, 40 feet around the aerator was open water. It never froze up.
Wow.
So, and we did another cold weather application just this December for a school. It's a Catholic school in Riverton, Wyoming. And they had mechanical aerators. They had the same issues, freeze ups and rag ups. And again, they could not keep these things running, constantly ragged up. And they had 3 of them, and they were all laying on the bank. And the problem was it was going into winter and it was getting cold, and their system had failed, and the lagoons were not very big and they're pretty shallow. And the concern was that the lagoons would freeze solid. And if that would have happened, the school would be out. 300 kids would be out of school because they would have no sewer. And working with the Bureau of Indian Education and Bureau of Indian Affairs, who provided the funding for this project, we got in there, we did an emergency installation. We took a big digger derrick with an 18-inch auger, big auger on it, and we got it out there, and there was 15 inches of snow and 12 inches of ice on these lagoons when we got there. And we literally had to break 12 inches of ice with these augers and drop 2 of these aerators in and got it up and running. And that was the second week of December, and it was in single digits. After we got it up and running, the temperature dropped, and for the next 3 weeks, it ran anywhere from -10 down to -40. And they never slowed down, they never quit running, and the ponds did not freeze solid, and the school is operational now. So we actually saved that school. They'd have been shut down all winter. If we'd have been 1 week later, we probably wouldn't have got them in.
Right.
So the cold
Lewis,
weather installations are really important.
Great. What is the website where people can get more information?
www.tituswws.com.
Okay, so it's tituswws.com now.
Yes.
Okay.
Yes.
All right.
We have our company has a new name. We used to be in Titus Industrial Group. We thought Wastewater Solutions fit our company more. So when we moved our operation from Oregon to Wyoming, we changed our name. Same company, mostly the same products.
All right. And you can
We
also connect,
also,
you can also connect with you on LinkedIn at Lewis Titus, and it is spelled LEWISTITUS. And Lewis always invites connections and engagement on LinkedIn to share information. And he is just he's a very interesting person to talk to. He knows a lot about the industry, has been around. He's a sewer rat like me, been around for a lot of years, and is very generous with his time and sharing all kinds of information and findings. So I would encourage any of you, if you found this conversation fascinating, to reach out and begin engagement. And let's just keep the information flowing and the innovations coming for the industry, because that's why we're all here, is like, let's just make it all better for all of us. And so, Lewis, I want to thank you for your service to the industry and coming on the show today and sharing the information about the product. And for those of you joining us, thank you for being here today. And I hope to see you on another episode. And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.